GAC, hope you're having a great day. This is Precal review, chapter 7, part 2. Hope you're having a fantastic day. I wanted to do this podcast just as a sequel to the first part from yesterday, and hopefully both of these will help you on the test. So without further ado, I wanted to hit on the first problem, which in this case will be problem 8. And this one's a little bit tougher. One of the things on problem 8 that I wanted to address with you is the fact that anytime I have something that's x squared within it, this is excluding the ones where we use our calculator, like number 5. So on number 8 on this one, what I would recommend in any type of situation where we have an x squared alone, what I would do is execute this problem by substitution, okay? Anytime. If you do it by elimination, you could get messed up and it could provide 2 different answers, which is not what we want. So what we want to do here is isolate x squared. Usually we isolate whatever the squared is on either side. Okay, and we can do this by saying x squared is equal to negative 2y plus 5. And we did get that there. Now, once I get this, I can substitute this in for the x squared of the bottom to where we get 3 times negative 2y plus 5 plus y minus 1 equals 0. Okay? Equals 0 there. All right? Want to make sure. Yeah, okay. Actually, it should be minus y right here. It should be minus y. Okay. Now, once I distribute 3 across, I get negative 6y plus 15 minus y minus 1 equals 0. So I combine like terms to get negative 7y equals, or plus 14 equals 0. And I can subtract 14 both sides, subtract 14. To where then negative 7y equals negative 14. Divide by negative 7, divide by negative 7. Y would then be equal to a value of 2, okay? Now, once I plug this in, the easy thing to do is then substitute 2 back in for the part that we had already isolated. So once I plug that in, this will be part 2 here. My second part will be x squared is equal to negative 2 times 2 plus 5. So 2 and 2 make negative 4, plus 5 is 1. X squared is equal to 1. We square root both sides to where x is equal to plus or minus 1. So once I combine this together, I get 1 comma 2 and negative 1 comma 2 to where my 2 solutions would be listed below. Okay? We'd leave that as is. Remember, with any time we have an x squared here, it's very important that you first substitute prior to then going through and finding what our answer would be there. All right, let's go to our next one, number 9. Number 9 to 1, again, where we could possibly do one of 2 things. I could use elimination or substitution. I see elimination much easier than substitution, where I can multiply the values to get the x's to where they're the same number but different signs. So once I multiply top by 3, I can multiply the bottom by negative 2. So in equation 1, I get 6x plus 12y equals 21. And on equation 2, I get negative 6x minus 12y equals negative 10. Now the x's cancel out. The y's also just happen to cancel out as well, producing a value of 0 on the left. And on the right, we get a value of 11. Now, since those values are not the same, our final answer, because we have no solution, because 0 cannot equal 11. Okay? All right, number 10 would be another one we could look at here. Again, I'm going to try to get the x's or the y's to where they're the same number. Maybe let's do the y's this time. Let's multiply the top by negative 4. And the bottom will just keep the same, okay, or multiply by 1. So the top equation would be 4x minus 12y equals 8. And the second equation on the bottom would be negative 4x plus 12y equals negative 8. Now the x's, they cancel. The y's, they also cancel. Giving me a value of 0 is equal to, and 8 minus 8 would also be 0. So 0 equals 0 would be all solutions or infinite solutions. That again would be my answer to number 10. Okay? All right. Now, if we keep going, we could keep solving for some of these systems of equations by doing the same method. Number 11 would be one that you could again do elimination with, or substitution would be hard on that one, but that's possible. Number 12, I think we talked about this one in class, where the top one I could multiply by negative 10, which moves the decimal over to the right. So in equation 1, you could say negative 35x plus 23y equals negative 1. Sorry about that. Negative 1 right there. And then the second one we could just drop. So 35x plus 12y equals 106. So the x's cancel, y's produce 35y, and 107 is what I get on this side. Actually, I'm sorry, 105, because this was negative 1. Negative 1 plus 106 is 105. So divide by 35, we get an answer of y equals 3. Plug 3 back in to produce the value of x. Plug it in for either one, and that would work out there. On number 13, just to give you another practice or crack at this, because we're trying to find the number that goes into both 5 and 2, we're going to distribute the value of 10 into all three of these expressions there. On the bottom one, we can multiply that by a number of 4 that's there. So in my first equation, we get 20x over 5 minus 10y over 2 equals 40. And in equation 2, we could get a value of 4 over 4x plus 4 over 4y equals 28. Okay? So in equation 1, we get 4x minus 5y equals 40. And on the second one, we get x plus y equals 28. Okay. Now, substitution is a possibility here. I'll do that just so we do something different. So this would be x equals 28 minus y. 28 minus y could be substituted in for the y that's on top. So we could say 4x minus 5 times 28. I'm sorry, back up. Substituting in for x, not y. 4 times 28 minus y minus 5y equals 40. So now we solve 4 times each of these. You kind of see how this goes. And I know that all of this, when done, sometimes it gets a little monotonous, a little boring, but something that shouldn't be too hard for us there. So I got on the right side, I got 1, 1, 2, I believe. 2 carries 3. Yeah. Minus 4y minus 5y equals 40. I'll kind of bring it over. I'll subtract 112 to both sides, getting me 72 on the right side, negative 72 on the right side, and on the left side would be negative 9y. Divide by negative 9, divide by negative 9, y equals 8. I like elimination better, it just goes quicker. That's up to you. When I plug 8 back in for y, I get x is equal to 20. Okay? So those would be my 2 answers there for solving the systems that's there. Number 14, and we're going to get to some other stuff here in just a second. The easy thing to do here is noticing that this 5y equals negative 9 by just dividing by 5. Now, you could work with a decimal if you want to. When plugging this back in, I'll keep working with a fraction. But since y equals negative 9/5, we're plugging it back in for y. So we get, right now, negative 3x plus 2 multiplied by negative 9/5 equals 4. So now I can say, all right, here we go. 2 times negative 9 is negative 18 over 5 equals 4. Now, just like I did earlier, it is very possible that since this 5 is here, I could multiply all of 3 of these values by 5. That's very, very possible. And in fact, I could do that. So multiply this by 5 is what I do to one side, I can do to the other. In top, only the top, as long as I do it to the same side, we're good. So we get now negative 15x minus 90 over 5 equals 20. 90 divided by 5, this right here would be 18. This would be 18. So I'm going to add 18 to both sides here. So I get negative 15x is equal to 38 divided by negative 15 divided by negative 15. I got negative 38 over 15 is my answer that's there. Okay. All right. I hope that was helpful for y'all. Hope that was. Again, there's a lot of maybe questions in regards to just plugging in and what that looks like. But that's how we would execute number 14, one with a fraction. Now, my last one that I want to hit before I get to some of the word problems to wrap it up is this three-system equation. What do I do with that? How do I execute it? And then we'll go from there. So the first thing I need to do is isolate a variable in one of my equations, either 1, 2, or 3. Now, since the first one looks pretty good, we're pretty easy there. Let's say that x is equal to, let's subtract that y and z by saying 6 minus y minus z is equal to x. So we're going to hold on to that. Now, keep that in white. And these other two, numbers 2 and 3, we're going to rewrite to where if x is equal to that, we're going to substitute in for x in both numbers 2 and 3. So we would, on number 2, say 6 minus y minus z is what we plug in for x, plus 4y minus z is equal to 2 on number 2. Now on number 3, we're going to put in the same thing, except this time we're plugging in for x, plugging this in. Okay, and so this is numbers 2 and 3. Notice that y and z are my two variables. We have two variables, two systems of equations because we substitute in for both of them, right? So now let's just combine like terms. So the y's would be 3y minus 2z. Let's subtract 6 to both sides so we can get rid of that there. So that equals negative 4. So this is equation 1. Equation 2, we got to distribute this 3, right? Did I already? Yeah, okay, I didn't have to distribute up there. So I get 18 minus 3y minus 3z, and I'll just rewrite this so I don't mess up, because sometimes it is easy to mess up. I'm going to subtract 18 both sides to get negative 15 equals, combine the y's, so negative 3 minus 2y is negative 5y, negative 3z plus 2z is negative z, and this is equation number 3 there. So we got equation 2 and 3, or there's two separate ones here. The easy thing to do here is probably elimination, where we can write these out. So I'm going to rewrite these so they're over top of each other. There's the first one. Here's the second one. Again, it is a little monotonous, isn't it? It's a little bit particular, but I don't think it's extremely hard, because once I get to this part, it's pretty much the same thing, right? Maybe a little step or two different. Pretty much the same thing. So let's multiply the bottom by negative 2 to get 10y plus 2z equals 30. Make sure the signs are turned into positive, and they all are. We bring this one down below, bring it down below here. So we got 3y minus 2z. We didn't touch this one. We didn't need to. Because now we got z's cancel to produce 26 is equal to 13y. Divide by 13. Y would be equal to a value of 2. Now, in plugging this back into any one, we could plug it in for this one over here. We could plug 2 in. We get negative 10 minus z equals negative 15. Add 10 both sides. We get negative z equals negative 5, or we could say z is equal to a value of 5. Now, to finalize it, I like to put it in probably one that was the easiest, which is the top. So we get 5 plus 2 right here is 7. So you get x plus 7 equals 6. Subtract 7 to where x is equal to negative 1. To test it, you could just pick an equation, either 2 or 3. Plug all 3 of these back in, x, y, and z. to see if it really does equal those values that are there. Okay? The only other ones I wanted to address with you before I sign out here is these two. Remember on number 7, that's important to set the supply equal to the demand. I believe that's on the podcast in part 1. The only other part that I would recommend in part 6 or number 6 is to know what is my revenue. What am I getting? What am I getting? And in this case, if I'm selling it for $9, the revenue that I would get per item is 9x. That's what I'm looking for. And my cost, what is it costing me, should always be less than my revenue. Otherwise, I'm not going to have a very profitable business, right? The $5,000 was my initial investment, no variable attached. That's a flat cost. And then I add what it took to produce it, which was 7x, right? And then so this is what I'm getting as revenue. What it costs is the amount that's going out of my business, okay? So what do I do with these two? Well, remember, this is where I set both the revenue and my cost equal to each other, and then rock and roll from there. Hey, I hope this was helpful for y'all. I really do. I hope that we went through a lot of questions that maybe you had either in part 1 or part 2. Again, the big thing, maybe the new part for you, make sure you understand matrices. Word problems is a huge key. Systems of 3 equations algebraically, that's a good one too. And then my last one with x squared, remembering to substitute in instead of using elimination. That's a huge part in getting the correct answer that's there. Hey, I hope that everything was good for you. Come in tomorrow for some extra help, or Thursday. Have a fantastic day. Almost there, y'all. See ya.